Hi, welcome again. So in this lesson, we will learn about some important machine learning terms like labeled data versus unlabeled data, input features and target variable. And we'll try to understand these terminology within the context of doing some machine learning tasks and machine learning projects. With that in mind, we'll learn this terminology. So before we get in and talk about some of this terminology, let us read this statement. As artificial intelligence becomes less of an ambiguous marketing buzzword and more of a precise technology, it's increasingly becoming a challenge to understand all of the AI terms out there. There are too many terminology out there. So like unsupervised learning, regression, classification, natural language processing, artificial neural networks, algorithms, cluster analysis, decision trees, deep learning, supervised learning, cognitive computing. So there are a lot of terminology that people are talking, and there is all possibility for us to get overwhelmed as we try to understand and differentiate each of these terms. So below I have two statements uh, how to learn this terminology. So let's read it and please think along with me and suggest whether the statement is true or false. So the first statement is the only way to master machine learning without feeling overwhelmed is to learn it in context. Do you agree with me or not? So what we are trying to tell is that if you don't want to get confused with these too many terms out there, if you try to think them in the context of doing work, in the context of doing some machine learning tasks, then that is the best way. Do you agree with me or not? Yes, you are right. That is the right way. In context of doing projects, if we understand systematically, incrementally this terminology, your conceptual clarity will be much better. So we will follow that method in our class. The second statement, let's read it. You should start with and focus on individual algorithms and not pick the right machine learning task for the job. Do you agree? Again, let me read for you. You should start with and focus on individual algorithms and not pick the right machine learning task for the job. So the first part of the statement is coming from more of this academic machine learning orientation, because academic machine learning orients on algorithms and algorithms and algorithms, and they go deep inside that. So that way, if you follow this whole topic, you may get confused. The better way is to actually pick the right machine learning task for the job and then around that understand the terminology. So this is a false statement. Yes, you are right. So with this understanding, let us try to understand some of this basic terminology. So let us start with the labeled versus unlabeled data. So this is one very important term. So what is labeled data? So as we perform machine learning tasks, we deal with lot of variety of data to either make decisions out of the data by understanding the underlying patterns or to do prediction for the variables. So with that in context, let us understand labeled data. What is labeled data? Labeled data are data sets that have a target variable. The label represents the ground truth to use when building a model. So labeled data contains so-called what we call the target variable. So we have a set of data and a particular set of independent variables. There is a target variable that is available and that is given to our machine learning algorithm. So a ground truth has been given. Then that kind of data, if you are handling, we call it as labeled data. We'll take examples. So let us take the terminology of unlabeled data. So unlabeled data, they are data sets that do not have target variable. Because there is no label, there is no ground truth. So the target variable is the ground truth for the data. If it is existing, then we call it as labeled data. If it doesn't exist, we call it as unlabeled data. I'll give you examples. Don't worry. but the difference between labeled and unlabeled data determines the categories of machine learning tasks that are possible for the job. We'll talk about it. The supervised learning and unsupervised learning tasks depend on whether you have labeled data or not. So with that, let's keep very clearly what is labeled data and what is unlabeled data. So example is that there is a famous iris data set. Here there is a database with all the flowers, different flowers, the petal width, petal length, and sepal width and sepal length. Based on that, the species of the flowers is decided. So here, if you look at it, there are four inputs, features we call them, and based on that, there is a truth or a target variable called species is available. So if you give this kind of data to your machine learning problem, then we are dealing with labeled data set. So here it is a labeled data. So sometimes we work with, this is a transaction data. This example here that you are seeing now, it is a transaction data of an e-commerce site where customers are buying and these invoices are being created. So here it's a data which doesn't have any labels, any target variable. It's a continuous data of various transactions with invoice numbers and what quantities, who is the customer buying it. That's it. So this is an example of unlabeled data. Just keep this in mind as we try to understand rest of the terminology. So again, as I used some terminology like input features. So whenever we are seeing a data, there are a set of elements in the data, we refer to them as input features. So input features are the variables that your machine learning algorithms can learn from. So algorithms that we use, they actually use the input features to build models. So input features, you have to always keep it in your mind. So input features are required for both supervised and unsupervised learning. We will learn also what is this supervised and unsupervised learning little later, but let's focus on what is input feature. So input feature, a lot of times it is also called explanatory variable, independent variable, regressor, controlled variable, driving factors. These are all variety of terms people use to refer to input features. But we will in this class keep on talking about input features. So in this example, if you look at what are the input features, the characteristics of the flowers represented by the length and width of petal and sepal is actually the input features. Based on that, we are determining species of that particular flower. That is actually our target variable. So input feature is this. So hope you got clarity with this. Let's talk about target variable now. So what is a target variable? A target variable is the output variable of a machine learning model. So during training, it also represents the ground truth for each observation. So if the ground truth is available in the data set, then we are calling it as labeled data. And a target variable is required for supervised learning. It can be a numeric kind of variable, or it can be a categorical variable. So let us also now focus on just defining target variable. So it's also called sometimes outcome variable, dependent variable, predicted variable, response variable, class in classification kind of problem, and sometimes it is simply called label. So here in this example, if you look at it, what is the target variable? That is species is the target variable. And what is the nature of this target variable? It is one of three categories. It is not any numerical value, but it is a class kind of output. That's why we refer to this as categorical type target variable. So let us take another example where we are dealing with some real estate transactions. So here, what is our target variable? There are a lot of input features like transaction here, the bedrooms and bathrooms, square feet, all that, but the target variable is the transaction price. So what is the nature of this transaction price, this target variable? It's a numeric type of target variable. So keep that in mind. So there are input features, there is target variable. If you have a target variable or the ground truth specified in your data set, we are talking them as labeled data. If you don't have, we are calling it as unlabeled data. So before we conclude, let us quickly do a knowledge check. If you are training the machine to predict how long it takes to drive home, which one of the following is a dependent variable? Weather, time of the day, holiday, or commute time? Hope you understood the question. You are building a system to predict the commute time. So what is your target variable? Yes, you are right. The commute time is the target variable. So let us go to another question. So we have a HR database here, very simplistic HR database. So to predict whether an employee will resign or not. So in this table, what do you see and what is the target variable? There are a lot of features there, but one of them is target variable. So what is the target variable? So there is a department, there is a last evaluation, number of projects, salary, recently promoted, status, whether left or employed, and tenure of the person. So in this data, what do you think is the target variable, which is a dependent variable? So you are right, that is the status. So, and what is the nature of this target variable here? It is either left or employed. So it is a binary kind of class. So it is a binary value, left or employed. So keep that in mind. The target variables can be of different nature. It's a categorical, but it is one of the two categories it can take. Either some employee left or employed. So that is why we call it as binary. Then let us take another example of our iris database. So here is a data set for predicting which species does a flower belong to. Which one of is the target variable here? Yes, you are right, it is species. And what is the nature of this target variable? Yes, it is a multi-category discrete value. One of the three species between those Setosa, Virginica and versicolor. So it is again a categorical type of target variable, but it has more than two values. It's not a binary kind of category. It has more categories. Keep that in mind. Then another, the real estate problem, let us take it. So what is the target variable here? Yes, you are right. It is transaction price. But what is the nature of this target variable? Yes, it is a continuous numeric value. So a target variable can be a binary categories classification, binary classes, or a categorical value representing more values, or it can be a continuous numeric value. And the last example and last thing you tell me now, here is a customer order data set for building a recommender system. Which one is the target variable? So there is a huge data of transactions here. Is there any particular attribute you can take it and think about it as a target variable here? No, it is just a series of data of various transactions. So there is no target variable. So you will have data sets with target variables as well as without target variables. Again, when you have target variables, they can be binary categories of two, or categorical values representing more than two values, or it can be numeric continuous values, or sometimes you may not have a target variable at all. So hope you have understood this and keep this terminology in mind to build our understanding on supervised and unsupervised learning. So what is the nature of the target variable here? There is no target variable. So let learn and have fun. Thank you.